What would it look like if we took a Tesla motor, a Chevy Volt battery, steel pipe, and a Ford Explorer axle and combined them together to make a rock crawler? Well, let's take a look.
Hey, welcome to this episode of Making It Work. We've got a little something different going on today. As you can tell, we are not in our usual
Recording
house
studio
or shop.
Yeah, we're in a different city, and we've had an invite to come and look at and go over something new that we've never shown on this channel. I really think you're gonna like it. It's really kind of cool, and so we'll get at it right now.
Come on in, take a look. This is the Avenger. Maybe you've seen it on 4x4 Nation or other such rock crawling type videos. That I don't know that much about it really. I know it goes fast and has a lot of horsepower. Let's go see what's going on. Lots of interesting things in here. Hey, what you working on?
Hey, sister.
How you doing?
Working on this little project.
Oh, this is my brother Chad. Y'all may know him from 4x4 Nation and numerous other little things that he's done over the years. But so, what are you working on here?
Well, we're putting a Tesla motor into this UTV race car.
Oh my gosh, what got you interested in doing that?
You know, I was kind of ruined one day when I took a Tesla S series for a test drive, and the 0 to 60 in less than 3 seconds.
Oh my gosh.
It's like, and I thought, okay, I've got to have one of these or build one of these or something. So we've built several little UTVs and the bigger V8 versions before, and we can do those all day long. I mean, it's a challenge, each one is,
Sure.
but I know that space. This is new to me, and it's a big learning curve. So yeah, we're going to take on the challenge and make it work.
So you've done this kind of thing before, or?
No, not really.
No?
We just thought it would be a real challenge after driving that Tesla, you know, test drive at the dealer, and that thing was so fast. It's crazy. Thought we've got to do this some way, shape, or form. So thought about this little UTV car, and we built this about 5 years ago. 180 horsepower motorcycle engine.
So you built this?
Yeah, we built it from scratch. We had a
Right.
truckload of tubing and that tubing bender over there on the wall, just a hydraulic, electric over hydraulic tubing bender. And we built the whole thing from scratch, the arms, the suspension, my friend Todd and I built it together. And so anyway, it was fun, it was fast, but then all the other racers were getting bigger motors, faster, and we couldn't keep up anymore and couldn't win any more races. So I thought, if we put a Tesla motor in there with 300 horsepower and immediate torque compared to the 180 horsepower gas motor, that'll be incredible.
Okay, so tell me like the difference between the torque on this electric motor versus because you have a higher horsepower.
Well, the Avenger's about 780 horsepower and 800 and some pounds of torque. It's a big block V8, all souped up and everything. It's a totally different way to measure power, and I'm not going to say I'm an expert at it. I just know that when I drove that Tesla, the torque being immediate is something I hadn't experienced before, because gas motors have to rev to their optimum RPM before they gain the most power, torque and horsepower. And the electric motor has its maximum power right from the first RPM. So it's hard to describe. But.
Do you know of anybody else doing something like this, a project like this?
Well, I've seen some people on the internet doing a rear-wheel drive version of this, but I haven't seen anybody do a four-wheel drive version, which is more difficult. I kind of wish I'd have just started with the two-wheel drive now, but we're too far into it to stop. So I'm sure there's other people out there that I'm not aware of that are working on them too, because it's getting to be pretty popular. Well, not popular, but for folks that really want a challenge, that's a challenge.
This is it, yeah. I can tell just by looking at all these little parts and stuff. So did you buy a kit Or did you just buy parts and you're got it in your head putting it together?
There's not a kit for this. If there is, I'll be the one making the kit. So there's not a kit. There's just all these ideas we had. We got to make a charger rack with 3 of those big chargers on it, different drive shafts, control switches. We got all our lists here, and we just dream it up and then start making it happen. EV West is a company in California that has been really helpful and knowledgeable, and so we bought some of the electronic components from them, like this DC to DC converter, for example, and the T2C computer that runs everything, and then you've got to have your battery control modules, and there's a lot to it.
A lot of components to it. A lot of components. So it's not that you got into this because you think EV is going to save the world or anything. It's just one of those.
Well, EV has changed the world for sure already, but I don't think that EV cars are really going to help with the world's emission problems or energy problems the way some people think, because you've got to mine for that cobalt and other materials to make the batteries, and that can be more invasive than mining for oil, for example, drilling for oil. And then once the batteries are played out and expired, what do you do?
Right.
So, and plus I think something like 80% of the world's electricity, or in the US anyway, is made by fossil fuels. So
Agreed.
it's maybe not going to fix the world's emission and energy problems.
But
like
it's going to fix that. It's going to fix that little accelerator.
I like them because they're so fast. It's amazing. So I'm all for EV cars. If you want to buy one, I may buy one. If they had more charging stations, I probably have one already because they're fun. But I don't know that they're going to fix all the things that people.
So what will your runtime be on this?
About 2 hours.
Okay.
And that's an estimate. It depends on how you drive, of course, and I like to drive fast, so we'll see. Hopefully 2 hours.
Yeah. How long have you been working on it? Like,
Well,
when did you start this project?
We started that project earlier this year, so probably 10 months ago.
Okay, so this has been, it's
Well, I think
a long time coming. It's
I
not
started,
something that
I did
you
some
work
other
on
projects in
constantly.
between.
Okay.
That delayed. I haven't really put a lot of effort into it just lately, but now I'm
Gotcha.
finished with the remodel of a building I bought, and so now I can get back on this. I think
Gotcha.
about 40 more hours in this, and it'll be running on its own.
Really?
Yeah.
That's not bad. I mean, that's very doable.
Well, I've already got a lot into it.
I'm sure you do.
But it's a challenge.
So tell me what's going on over here with all of this spaghetti mess that's going.
Yeah, that's kind of intimidating. This is not my favorite part of the project.
I
So
don't think it would be my favorite part.
all
either.
these tiny little tags we put on there, the numbers, they coordinate with the ends here and here, one on each end. This goes on top of each of the battery modules, and there's 96 cells inside.
Oh my gosh.
All 3 batteries together, there's 96 cells. So each one has to be monitored for voltage and temperature. And if they get out of parameter, then these little ECUs, these are satellite control modules
Okay.
for each of the 4 parts of the battery modules, and then this MCU, master control unit, coordinates all the data from these, and there's plugins on each end. There's quite a bit that goes into these. And that monitors all the data and sends it to the T2C, which is over there, the main control module, and then it shows up on this iPad on the dash through Bluetooth.
So you'll be able to keep track of like how high the batteries are, like
you have to, because you ever see one of these start on fire?
No.
It's not pretty, and you
I
can't put it out.
I saw something of yours start on fire one time.
Oh,
That was
that's
several
happened.
years ago.
It's happened a few times. There's an onboard diagnostic system in the T2C that coordinates with this MCU, master control unit, and it'll give you codes.
So you don't have to go to a dealer or somebody like that to tell you what's going
I don't
wrong?
think the dealer would be able to help or want to. So we have to make this Tesla motor think that it's still in a Tesla car. That's the challenge.
Oh.
And so this wiring diagram, for example, that's the T2C controller and all the outputs on it. And then here's the output on the Tesla Model 3 primary wire that comes out of the back of that.
How did you decide like how many batteries you would need and stuff? Does the battery change the torque somehow?
Yeah,
It does?
I had to do a lot of research on that, and there's a lot of options for batteries. You can buy brand new batteries from a number of different companies. You can buy things from salvage yards, and they're readily available because they turn these cars over and make a lot of money on the wrecked Teslas. So the Tesla batteries were going to be the most powerful, and I could have put those in there, except they're 840 pounds.
Ooh.
And this little 1,800 pound vehicle, that's too much. And so
what kind of batteries are in there?
Chevy Volt batteries are only 360 pounds. And they'll do the same thing, just not for as long of time.
So you're combining like Tesla control stuff with a Chevy Volt battery.
That's right, that's right.
Okay, interesting. Should we take a peek at that stuff?
Yeah, yeah. Come on back.
So, you were telling me about, you've got Tesla control and...
Yeah, we got a Tesla Model 3 motor in there. You can see that down in there.
Oh, okay.
Underneath. Pretty shiny silver. And that was fun, putting that in there, fabricating the mounts, making the drive shafts and all that. That's really something I'm used to. I can do that all day long. It's the electronics and the battery stuff that has been a challenge and a lot to learn. So we have our Chevy Volt batteries. There's a unit here and one on each side, so 3 total. This is actually 2 in 1, so there's 4. That's why there were 4 satellite control module boxes over there with 1 MCU, and those will get mounted in the top. There's actually fiberglass boxes that go over these to make them waterproof. Because water's not your friend with a battery like that.
Yeah, I'd say no.
In case you get submerged when you're racing.
And these are the plugs that you were showing us over there.
That's right, those big orange plugs go right in here.
Okay.
Yeah, yeah. And then you've got to run your high voltage wires, which these large orange wires are. These are huge, they're 2 watts. And probably overkill, but I'd rather have overkill. So there's a big switch over here, turns the system on and off. There's fuses after
Did this used to be the gas tank? That's what it looks like.
It looks like it. Not really though. But there's fuses, large fuses after every battery. So, it's a redundant way to bring some more safety to what we're doing. Yeah, so we have Chevy Volt battery packs. It's 360 volts. And the Tesla Model 3 is, it runs best at anything between about 350 and 410 volts. So we're at 360, that's close to ideal.
Okay, awesome. Yeah, I was curious. I didn't realize that you were using like different batteries, like one brand of battery and one brand of control modules and stuff. So that's interesting. Using what you have and making it work. Yeah, we
use a different kind of battery control module system, the control system from EV West, and then we use another controller that actually comes from a company in Canada, but I bought it through EV West, the T2C, and then we've got an iPad on the dash. It's pretty generic and simple, but those are for the battery temperature management. They just plug in the side of the battery. I don't know if I'm going to use those or not. They go right in these little plugs right here. So I may be able to do it without those, because those battery control modules, the BCM, they can run without those. So we'll see. I don't know yet.
So it's not the battery or the motor that necessarily makes it 4-wheel drive. It's the way it's your drive.
Yeah, the battery has nothing to do with 4-wheel drive or not. The Tesla Model 3 came in the Tesla as a transverse unit where the axle shafts came out of the transaxle and went to each wheel to power the wheels. I've turned that longitudinal in the vehicle, so now instead of powering each rear wheel, one of the drive shafts, axle shafts converted to a drive shaft, goes to the front differential, and the other one comes out right here to the rear differential. And that way you have four-wheel drive.
Gotcha.
Yeah.
Awesome. Awesome.
Making it work.
Making it work.
Whatever you got.
And taking what you have and making it work. Sometimes you gotta buy parts though.
Yeah.
Did you say that this thing needs to think that it's still in a Tesla in order to really work?
Yeah, really, for that Tesla Model 3 motor to work, it has to think it's still in the Tesla car. So we have the T2C controller that has the software in it to give the motor everything it needs so it thinks it's still in the car.
Gotcha.
Yeah, and there's a lot to that because there's a whole lot of things that have to happen properly for that motor to work.
Mm-hmm. And it needs to, what about temperature and stuff? How's that affected?
Yeah, good question. So see these little tubes coming out of the batteries?
Mm-hmm.
Those are all water cooled. So we have a radiator.
I was just gonna say, so it's got a radiator.
Yeah, it's got a
just
small radiator. It fits up in here behind the passenger seat, and I've got it all set, except the brackets have to be made. And there's a little fan on it. So
Okay.
it runs antifreeze through all 3 battery packs
Oh, wow.
and the motor. The motor has to
Oh.
be cooled as well. Who would have thought, right?
Right?
Yeah, so it's not as hard as cooling a gas engine that has combustion and hot things happening inside of it. This just has the friction from the bearings in the motor primarily and the gears that are running together in the transaxle. And then the battery generates heat, when it
Right, yeah.
expels its energy. Or when you're
Exactly.
charging, it heats up then too. You got to cool it both ways.
Are those big silver things right there, are those the fuses?
These right here?
Yeah.
Those are fuses, and they're hot right now. They're hooked up. There'll be a cover over that box, and
How many volts are running through those?
it's 360 total, and you can divide that by this module together with that one make the top battery. And this one's smaller, and that one's, I forget how many cells are in each one, but each one has a certain amount of voltage. I think it's 2 point something volts, and together it adds up to 360.
Wow. Okay. So how are you gonna keep this thing charged?
Well, that's the thing with electric vehicles. They don't stay charged.
All right,
Cows don't stay
exactly.
milked, and the car doesn't stay charged. So we have these charging packs. And there's 3 of these.
That's
And
gonna go on here somehow?
I first purchased a Tesla Model S charging unit out of a used car, and then I decided it was water cooled and I didn't want it to be water cooled. So I got 3 of these, they're in boxes down there, air cooled, and all 3 will mount on a rack with wheels on it. So we take it wherever we go. If we go to the races,
Oh, okay, so it's,
we have to take it with.
something that has to go with it, but it's not gonna be attached to the vehicle.
it goes with it, and then you plug it in, when there'll be a plug-in on the side of that.
Okay,
So you plug in that rack with these on it, and you have to have 220 volts.
So you'll have to take a generator then too.
A generator, or most race tracks now have electric car charging stations.
huh,
Yeah, who would have thought?
interesting, yeah.
Because people are starting to, make these kind of cars.
Right. All
Earlier.
right, well, you told me earlier that you built this thing, like, how many years ago did you build it?
5 or 6 years.
Yeah, and all the parts you fabricated, or tell me about these.
Yeah, this was kind of an exciting project because a lot of times we buy axles, axle housings and all the parts. In this case, we got a truckload of tubing, and there's a tubing bender over there that we use to bend all the tubing. My friend Todd and I welded all of these. He's a better welder than I am, so I welded in the places you can't see as much, and he welded the pretty spots. He's a fantastic welder. He teaches welding classes.
Oh, wow.
So anyway, we bent all this tubing. We made these A-arms from scratch. We bought these heim joints and made all this stuff, and this is a Ford Explorer aluminum 8.8 differential, which is lightweight, and so far it's been strong enough. And then you can buy these axle shafts off the shelf at AutoZone or
Oh, really?
O'Reilly's or places like that for like $150 for the whole shaft. So if you ever break one, they're readily available. So
That's nice, because you've broken a few of those kinds of
man,
things.
I've broken everything they make. I've broken Dana 30s, Dana 44s, Dana 60s, Dana 70s, Rockwells. Yeah, everything. So, yeah,
Alright.
but I haven't broken these yet.
There's that.
Yeah, yeah. But we're gonna up the power by about 3 times as much, so
We'll see what
it's
happens.
gonna be a challenge, yeah, but we'll see.
So who's going to be the first one to break something? You or Bree?
Not me. Bree can tear some stuff up, that's for sure. That girl.
So you're charging with 3 of these that are on a rack, but does everything, like all the little fans and headlights and stuff, that all runs off of the same motors, or how does that work?
Yeah, that's a
Are
good
the same
question.
The same batteries?
That's
Yeah.
a good question. So that's 360 volts, and it really just runs that Tesla
might
motor.
blow
Yeah,
out
that
a
would blow
headlight, right?
everything. Yeah, boom. So we have another gizmo here. It's a DC to DC converter. So you run 360 volts in one side from the high voltage, those large wires, and out the other side comes just 14 volts like you would have on your car. I mean, you think, oh, it's 12 in a car, right? Well, technically this is like an alternator, and it's going to charge the 12 volt battery that I already have in this vehicle.
Oh, so
So it's like
that's
this is like an
one off.
alternator.
Got it, yep.
And it's going to take power from the big battery packs, convert it down, reduce it down to 14 volts to run the, like you said, the fans, the headlights, the horn, things like that, the
That's very
iPad.
important.
Yeah.
So-
So that's how we do it. And
That
it's
battery's not meant to start the car.
No.
just- yeah, there's no starting.
Is it, how does that work then? It's just always on and ready?
Well, no, good question. There's that big red button on the side. It's like a kill switch. And then you've got one on the dash where you flip the switch, like turning the key on, ignition on, just like the Tesla would have, or any other EV car.
I'm gonna have to take a ride in a Tesla.
Pretty fun.
All right, well, hey, thanks so much for showing us what you've been doing. Brother. What you've been doing here, and we'll be back in, would you say, 40 hours to take a test drive?
That's 40 shop hours, not 40
man,
like
too bad life just gets in the way,
I
doesn't it?
know, I
It
know.
really
If we could
does.
just like stay out here, this thing would be going already.
Yep, absolutely,
But there's other things in life more important than EV cars.
absolutely,
Yeah.
absolutely. But all right, well, thanks so much for showing us what you're doing.
And we'll come back when it's ready.
Yes, definitely. We'll be back.
Yeah,
We'll be
I'd love to
back.
take you for a ride in it. I bet she could squeal like a girl.
I might.
Maybe Tim too.
She probably could drive it, and you would squeal like a girl.
Yeah, that's scary.
I don't know if I've ever driven any of your toys.
We should put her in the Avenger first then. Start there and then everything else will be easy.
Yeah.
There you go. All right. Well, hey, thanks for watching this episode of Making It Work. Please like and subscribe and
Share it with a friend.
share it with a friend. That sounds good.